as a review, we talked about the product rule was such that the derivative of the multiplication of any two functions was equal to the derivative of the first function times the second function plus the derivative of the second function times the first function. Now that you've learned the product rule, now that you've spent 2 days of practice, both through Delta Math and through the online, now that you've done the product rule, the quotient rule is very easy. It's very much the same as the same application. I gave you 2 days of the product rule, because I had to go to the appointment yesterday, but also because you really want to solidify your understanding of the product rule, because it makes the quotient rule that much easier. It makes the quotient rule more just about memorization rather than trying to application. So, and today, like I said, you've already learned the product rule. You understand it. You did all your homework. So now we go to quotient rule. So the quotient rule is when we divide two functions. So a product means an answer for a multiplication, and the quotient means an answer for division. So the quotient rule says that when we take the derivative of a function, f of x, over another function, g of x, then the derivative answer looks almost identical, almost. So it is the derivative of the first function times the second function, but of course, since product was plus, like happens a lot in terms of exponents, quotient is minus, so it's a minus the derivative of the second times the first, but it's a quotient, so we have to have a quotient in our answer. The second function, or the denominator, squared. This is the quotient rule. This is one of the most important. These two formulas right here are two of the major formulas that you must memorize. The major formulas in calculus that you cannot get wrong. They need to be ingrained in your memory and not be able to make a mistake with them. We also say that we can also note that if we want to take the derivative of u over v, and we want to take the derivative of that, then it is u prime v minus v prime u all over v squared. So that's just another version of the same thing. It's the same part, like I said, but we utilize u and v notation rather than f and x function notation. Okay. Now we can do a lot more better examples on here. Now, when we were doing the product rule, because the only functions we've dealt with so far have been power functions, most all product rule problems that deal with it could have been solved using other derivative practices. In that case, by expanding. So in the problems that you saw yesterday and the problems that you saw the day before on Delta Math, you technically didn't have to use the product rule to do all of them. However, it was the most efficient way for many of the problems. The same cannot be said about quotient rule problems. Some problems can only be done through quotient rule. Remember, algebra manipulation can reformat a problem to be solved by various means. And what I'm trying to say here is that i.e. the derivative of x plus 1 times x plus 2. This problem requires the product rule as written, but it is the equivalent to saying the derivative of x squared plus 3x plus 2, which is simply power rules. And of course, the product rule, when I say product rule also requires power rules as well. You can't just do product rule on its own. But how you attack the problem is different, and you could have done expansion. In some of the problems that you'll see today, you can do algebra. Of course, here's the problem. You got to do good algebra. You have to do good algebra. There's so many mistakes that students make. Maybe it's just that you've been taught some method, and as a result, you keep making mistakes the way you were taught. It could be you try to do the work too fast and you end up making an algebra mistake. But algebra mistakes happen. So we also need to realize, remember, everything comes down to, in calculus, efficiency. It's a big, big, important word. Making sure you do the problem right, making sure you can do the problem rather quickly. But first and foremost, that you do the problem correctly. So efficiency is a two-pronged part. So get the correct answer. Get the answer correct. Do not make an algebra mistake. Do not make a derivative mistake. Now, calculus, if I gave you, and here's the thing, if I gave you a problem and I say, use this, calculus often isn't very hard. If I told you, here's a problem, use the power rule to differentiate, and it's already written in the format that you want it to be written in, then the problem is just very patterned. It's, all right, I can look at the notes and do it exactly like the notes say. That's the dream, but it's a dream. It's not what happens in calculus. In calculus, I say, here's a problem, find the derivative. But wait a minute, what rule do I use? Do I use a quotient rule? Do I use a power rule? Do I use a product rule? Do I use a chain rule? Is this a power function? Is this a trigonometric function? Exponential? Logarithmic? Oh, do I have to rewrite it? Oh, there's a radical. How do I change radicals? Oh, there's a fraction. Do I keep it as a fraction? Do I bring the powers up? Do I bring the powers down? How do I combine these? These are all questions that have to go through your mind when you tackle a problem. And I know I did it purposely in saying the way I said it. And the reason is because you have to, first and foremost, the number one most important thing in calculus is homework. The most important thing in calculus is practice. It's practicing on a daily basis, working on manipulating, getting the feel for a problem and saying, oh, you know what, I've done a problem. I haven't done this problem, but I've done 10 problems that are just the same thing. When I see a problem like this, I want to use this rule, so I'm going to rewrite it so that it looks nice over on this way. Let's look at an example. And the first example will be something that we're going to just straight up use the quotient rule. F of x equals 3x squared plus 5x plus 2 over 4x squared. Now, this is a problem that you can do two different ways. I could have technically, and I think, did I? No, maybe, no, I didn't. I could have given you this problem when I first introduced you to the power rule. So you can do this problem using only power rule. Okay, so only the power rule, but in your homework, I'm going to tell you explicitly to use the quotient rule. Only the power rule would mean that we want to rewrite f of x, algebra. Can anybody tell me how I rewrite this problem algebraically? What is the algebra step? And this is something, if you don't know what I'm doing right now, when I do these algebra parts, you need to practice. You need to get tutoring. You need to come to office hours. You need to make sure that you do not leave your homework going, well, I didn't know how to do that. Oh, well, you can't. if you are having these problems right here, guess what? You're going to see about 100 different problems that look exactly the same thing that are going to require the exact same algebra manipulation I'm about to do. So you got to make sure that you do it. There's no excuse for not doing homework. There's no excuse for not setting up tutoring if you need that. There's no excuse for understanding and doing good algebra. We have to do that. So I know the first time I introduce you might be like, oh yeah, but you might be confused right now. But how do I rewrite this problem? How do I change this problem into only power functions? Anybody? How do I rewrite this using only power functions? How do I just rewrite this, simplify? If I ask you to simplify. Say sorry, my volume was down a little bit. Can you repeat that?
Top part would be 6x.
You said 6x? No. We're not taking, no. Algebra. So yeah, so if you want, we're going to get to that part in the second one using the quotient rule. But I want to talk about algebra. We divide. So this is the same thing as 3x squared over 4x squared plus 5x over 4x squared plus 2 over 4x squared. This is a step that you do in algebra class, your math 1, your math 2 class. This is the same thing as 3/4 plus 5/4 x to the negative 1 plus 2/4, which I know is 1/2, x to the negative 2. This is algebra. They're the same things. These two things are equivalent. Sorry, I'm suffering from a big migraine this morning. So that's the algebra. And now, when I want to take the derivative, I can say, oh, okay, so f prime of x is equal to 0 minus 5/4 x to the negative 2 plus 1/2 times negative 2 x to the negative 3. So f prime of x equals 5 over 4 x squared minus 1 over x to the third. When I simplify it down. That's the derivative. Now, like I said, I didn't use quotient rule at all. I did not use the quotient rule. This was just using algebra because I can rewrite this problem this way. And the reason why I was able to do that this way is because the denominator was a single term. That's very important because of that, and they're all power functions. I can use algebra to do it. But let's now just, as Friday was trying to do, let's just try to use the quotient rule. All right. So once again, f of x was equal to 3x squared plus 5x plus 2 over 4x squared. We're going to define the top as my u and the bottom as my v. So what is u prime? And this is what Ryder was saying. What is u prime? What is the derivative of 6x?
Plus 5.
Plus 5. And what is v prime?
8x.
8x. So u prime v minus v prime u all over v squared. And now we just substitute all that information into that formula. So f prime of x equals u prime, so 6x plus 5 times v, 4x squared, minus, I always like to use brackets for my derivative just to note in my formulas, minus v prime, 8x, times u, 3x squared plus 5x plus 2 all over the denominator 4x squared squared all over v squared. This is my answer. If you write your answer like that, that's full credit. But wait a minute. Didn't I just say the answer was 5 over 4x squared minus 1 over x cubed? That does not look like anything that I'm seeing right there. But it is. They are the same. If I were to expand this, and I don't want to spend the class doing this, if I were to expand and then simplify, I get that f prime of x equals 5 over 4x squared minus 1 over x cubed. All that ugly algebra stuff right there inside that quotient rule, all that stuff, if I square it up correctly, I get that. And I know you're looking and say, how does that become, how does this ugly thing become what I see in it? And it's just, there's a lot of stuff that cancels out. There's a lot of stuff that cancels out, and that's what it comes by. For example, 6x times 4x squared is 24x cubed. Well, guess what negative 8x times 3x squared is? It's negative 24x cubed. So the 24x cubes cancel each other out. And so you get terms that cancel each other out. The 4x squared becomes 16x to the fourth. It's just algebra. It's just a lot of algebra that comes down. Now, we are not going to bog down on, we don't have a lot of time. We don't have the practice. So if, algebra practice is good. So if you have the time to practice, try to practice getting to here if you have the time. It's very good and important to do. However, this is the answer. That whole ugly quotient rule part is the answer. Now, if it's a multiple choice problem, you are not going to see this ugly thing. You're going to see this. So, you have two choices on a multiple choice problem. One, you do the quotient rule and then you simplify. Okay? Or two, you simplify before so that you can get the problem like this, and then you recognize what the answer is going to be. There's no way about it. You have to get to the answer on a multiple choice. That's the problem. All right? Let's do another example. Now, the following example can only be done using the quotient rule. It can only be done using the quotient rule. G of x equals 5x squared plus 2 over 3x minus 7. Now, I want you to note there are two terms. The only algebra that you can do that can be done is bad algebra. What do I mean by that? I mean that if you try to simplify this and you try to go like, oh, I'm going to take 5x squared and divide it by 3x, and I'm going to divide the 2 by negative 7, that's bad algebra. And it's incorrect algebra. You're changing the problem. You cannot do anything to this problem. You must use the quotient rule. You must use the quotient rule. So, I identify my u, I identify my v. U prime, oh, that's 10x. V prime, oh, that's 3. And so can I get somebody to tell me now what the derivative of this function is? Just the rule. You're just copying on the quotient rule.
you want the u prime v minus v prime u all over v squared?
Yeah, but I want with this problem, yes, but with this problem.
Oh, okay. 10x times 3x minus 7 minus the minus sign, and then you do 3 times 5x squared plus 2 divided, and then 3x minus 7 squared.
Perfect. Are you going to see this on the multiple choice problem? Are you going to see the problem written like this as a multiple choice, though?
No.
No. So that's the answer if it's not a multiple choice, all right? But if it's not a multiple choice, you write your answer like that and you move on. You say, thank you very much. Have a good day. That's the answer. But if it's a multiple choice, we have to do some algebra, which just means clean the top. Don't do anything to the bottom, but we need to expand the top. So if I do that, I get 30x squared minus 70x minus 15x squared minus 6 over 3x minus 7 squared, which gives me 15x squared minus 70x minus 6 all over 3x minus 7 squared. And that's what you would see on your multiple choice option. So it's the process is, and when you're doing your homework, here's u. Oh, this is a function. This is a quotient. I need to use the quotient rule. All right. Here's v. Here's u. Here's u and here's v. All right. Now I need to identify u prime and v. Some people will not write. Some people don't like to write and choose not to do this, and they go directly to the answer. Okay, good for them. All right, hopefully they don't make mistakes, but most often they're going to make more mistakes. I've been doing this now for 18 years. I've been doing calculus now for 18 years, and guess what? I still write u prime and v prime on my paper because I don't want to make a mistake. I don't want to look silly as your calculus teacher, and I probably will. I'll probably make a simple algebra mistake. I'll say like 2 times 5 is 12, and I'm like, no, that's 10. And it's just because you go through problems and you make simple mistakes like that. But that's the answer, and we need to practice it. I can go over more examples, but I sometimes just it's the same process. The best thing for you is to do the problems, but also tables. I'm gonna go with table problems. Okay, so x, like we did on the product rule, f of x, f prime of x, g of x, g prime of x. Let's go with 2 and 3. Let's go with -1. I'm just making up values here. 4, 1/2, 6, 2, -3, -2, 1/3. Okay. I could have used the same numbers on my table from yesterday if I wanted to. But I have a table. So here's a table. And just like yesterday, I'm going to give you a function. All right? So in my example, I'm going to state that h of x equals, and the difference between these problems on tonight's homework, or actually technically tomorrow's homework, or technically it's Monday's homework. But if you have a tutoring session that you can set up today, or if you have the free time today or over the weekend, and you can work on these types of problems, then you should go forth and do it, even though this is due Tuesday. Tonight's problems on Khan Academy are very straightforward here's problems that are quotient rule, and of course, you're just typing in the answer. It's less, but showing your work is going to be the most important part, and you need to get that practice. Do not just write the answer down. So yeah, sorry, I said Khan Academy, but I meant Delta Math, and then the paper. I got like different things. I got you guys using Delta Math, and I got my other class using AP Classroom, and I got a different class that use Khan Academy. Some courses are built for different things. So h of x is equal to 2f of x over g of x. Find h prime of 3. Okay. Find h prime of 3. So remember, always, to find h prime of 3, I first need to find h prime of x, and then I can find h prime of 3. So how do I go about doing this problem?
We find the derivative of u and v.
Good. So I'm going to state that this is my u and this is my v. So I'm going to find the derivative of u and the derivative of v first. Okay, so what's the derivative of u?
-6.
No, no, no,
I
no.
meant
There's no number. It's not a definitive answer. We're talking about the function. Remember, h prime of x. You might get the right answer in the end, either because you feel very comfortable or you try to do too much in your head and you end up getting the wrong answer. So we want to take it step by step, especially since it's notes. And I want to show you as much step by step as possible. So what is u prime? And when I say u prime is a function, not a value. It might have a constant in it, but what is a u prime?
f prime of x.
Close. U is 2f of x. So what is u prime? You had to do this on your homework last night.
2f prime of x.
There we go. 2f prime of x. It's a constant multiple. And what is v prime?
G prime of x.
G prime of x it is. Yes. I like that. Have an anchor man. I'm Ron Burgundy. You gotta be confident. You got the right answer. You can do it. You got it. All right. What's h prime of x? Remember, u prime v minus v prime u over v squared. What is h prime of x?
You want the equation?
It's a function. Yeah, because it's of x. So when you see it says of x, then your answer is of x.
So wouldn't it be like 2f prime of x times g of x, and then it's a minus, and then we have g prime of x times 2f prime of x divided by
Whoa,
g
whoa,
of
whoa, 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 whoa.
2f of x.
There we go. All over.
And you divide by g of x squared.
Perfect. Just plug everything in. You got the 4 things. It's like a little puzzle. It's like, all right, I already know what this is. I know what this is, this and this. I have these 4 things. Here's a formula that asks me for 4 things. Place them in. Now, what is h prime of 3? Take it step by step. So what is h prime of 3?
Would it be 2 times -3? Is that times -2 minus 1/3 2.
What is it? 2?
Yeah. all over -2 squared.
Perfect. Of course, that's an ugly answer. Let's finally clean this up. Do a little bit, have some fun with some algebra. So this gives me, and what is that, 6? That's positive 12. Oh, I need to make this nice, huh? Minus 4/3 over 4. Multiply these by 3/3. That gives me 36 minus 4 over 12. And 36 minus 4 is 32 over 12, which gives me both divisible by 4. So I get 8/3. The last step was just cleaning up algebra. All these last parts right here, that's just algebra. That's simplifying, so that's just doing some algebra in here, just to clean it up. Calculus is literally the only thing you did on calculus was 3 things, or 2 things. You found the derivative of u prime and v prime, or u and v. You found u prime and v prime, the derivative of the top and derivative of the bottom. The next thing in calculus you did is you plugged it into the formula that calculus says to use for quotients. Then you read the tables and inputted the values. And then you had a secondary thing where you cleaned it up. I mean, if there's numbers, you don't want to, technically, if, like I said, if this was an open response question on the AP exam, then by golly, you leave your answer as 2 times -3 times -2 minus 1/3 times 2 times 2 all over -2 squared. You leave that answer like that and you say, you simplify it, I'm going to the next problem. Then you get to the next problem and it says, all right, using your answer from the previous problem, you're like, oh, now you got to simplify it down to get to that 8/3 to make the problem a little bit easier. Because what I'm going to do is I'm going to ask you questions like, find the equation of the tangent line. Oh, evil if you leave it like that. But now, oh, the slope is 8/3. All right, so then y minus, I need to find h of 3 equals 8/3 times parentheses x minus 3. Oh, that's it. I just got to find h of 3 now. I held off doing those types of problems. I'm going to give you those problems after we do the chain rule. So you will get some tangent line problems, and you'll get them soon. Quotient rule. You're practicing it on all your homework. You got the delta math, and then you have the homework handout. I thought I released the homework handout. I'm just looking at it right now. I did not. I'm going to release Monday's homework, which is the handout version, just like you did the product rule. Delta math first, do Monday. And then on Monday, we're going to have an asynchronous class time. I'm going to do a check-in. I'm going to make sure and see, have you checked in with your virtual sessions? Have you signed up? How is tutoring going? Why aren't you going to tutoring? Should you sign up for tutoring? All that kind of stuff. And just check out in terms of, just a quick check-in of how you're actually doing. And then you'll be working on those homework handout problems during that time. I don't want to push beyond all that information. I'm going to let you go and practice in class about 10 minutes early. You guys have a good weekend if you want to be gone. If you have questions about any of the things I just said, tutoring, the virtual sessions, the quotient rule, the product rule, the power rule, I'm here for the next 10 minutes.